These are some of the recent images of our solar system. Before the 16th century, this is how our solar system used to look like. Now, you see the difference? The leading role in this change was played by a scientist named Nicolaus Copernicus. So, how did he go from this to this? And what role does he play? Let's find out.
What exactly is a solar system?
A solar system basically is a gravitationally bound system of a star and planets. Gravitational force holds these planets and stars in a system. It consists of various elements, like a star. In our case, the star is the sun, along with various planets revolving around it, like our own planet Earth. There are also bodies like moons, asteroids, and comets. These elements of the solar system are bounded in a certain way, like a moon revolves around its planet. But our solar system was not always pictured the way we do today. Before the 16th century, people leaned on the idea of geocentrism. So, what exactly is geocentrism? Geocentrism is a model which places the Earth in the center of the solar system. Basically, it says all the planets including the Sun revolve around the Earth. It was a widely accepted idea in ancient Greek, Roman, and Islamic civilizations. Why, you may ask? It is because the geocentric model was also consistent with many religious beliefs and interpretations, particularly in Christianity and Islam. The idea of Earth being at the center of the creation aligned with theological views that emphasized humanity's special place in the cosmos. This is why this was the dominant model of the solar system for centuries. So why exactly people would believe Earth was the center of solar system? There are many factors which contribute to people's belief. The major reason is simply the intuition of people. It seems intuitive that the Earth, being the solid and stable ground beneath our feet, would be at the center of all celestial motion. Also, many religious texts, including Christianity and Islam, supported the idea of geocentrism. Like this text in the Bible, "He set the earth on its foundations, it can never be moved." This verse has been interpreted by many to imply that the earth is fixed and immovable, supporting the idea of a stationary earth at the center of the universe. Limited scientific equipment then also played a role in this. To put it simply, there were not enough scientific instruments to observe the true nature of the solar system. In the year 1543, Polish astronomer named Nicolaus Copernicus published his book named On the Revolutions of the Celestial Spheres, originally called De Revolutionibus Orbium Coelestium. This book was a major turning point in how we picture our solar system. It presented a mathematical framework that described the motion of celestial bodies in a heliocentric system. So, what exactly is heliocentrism? Heliocentrism is the current model of solar system which puts the sun in the center. This is the current model we use to describe our solar system. While Copernicus did publish the book, he was not the first person to propose heliocentrism. It had been proposed as early as the 3rd century BC by Aristarchus of Samos, but his idea attracted little attention, possibly because of the lack of proof and loss of his scientific works. Now you see, Copernicus was deeply influenced by the work of ancient Greek astronomers, particularly Aristarchus of Samos. He was not only an astronomer, but also a mathematician. His mathematical framework allowed him to describe the motions of the planets relative to the Sun, providing a more elegant and accurate explanation than the geocentric model. In his book, Copernicus presented his heliocentric theory along with detailed mathematical calculations and diagrams. It was further supported by observations made by astronomers like Galileo Galilei, which provided an alternative explanation for the motions of the celestial bodies. Over time, as more evidence accumulated in the favor of heliocentrism, the geocentric model gradually fell out of favor among scientists and scholars. Copernicus knew that his heliocentric theory could provoke controversy and opposition, particularly from the Catholic Church. He made his book extremely technical, unreadable to all but the most advanced astronomers of the day, allowing it to climb into their ranks before stirring a great controversy. He was cautious about openly promoting his heliocentric model to avoid direct confrontation with religious authorities. Copernicus died shortly after the publication of his book. After his death in 1543, his heliocentric model continued to face criticism and skepticism from both religious and scientific communities due to lack of direct evidence to support his claim. He relied primarily on mathematical calculations and geometric arguments to support his model, which made it difficult for some people to accept his ideas. Tycho Brahe was a Danish astronomer who made various observations of planetary positions without the aid of a telescope. These observations showed that the motions of planets could be explained more simply within a heliocentric model rather than the complex geocentric model. In the 17th century, Galileo designed and built telescopes with increasingly higher magnifying power. Galileo's telescopic observations revealed phenomena such as the phases of Venus, which can only be explained if Venus orbits the Sun and not the Earth. Galileo also discovered the 4 largest moons of Jupiter orbiting the planet. This discovery provided further evidence that not all celestial bodies revolve around the Earth, and showed that objects can orbit other bodies rather than Earth, supporting the heliocentric model. Kepler's law of planetary motion, derived from observations made by Tycho Brahe, provided a mathematical framework that supported heliocentrism. Kepler's law described the elliptical orbits of planets around the Sun. These laws provided a simple and elegant explanation for the observed motions of the planets. Later, Newton, with his laws of motion, showed that the same physical laws that govern motion on the Earth also apply to celestial bodies, allowing for the mathematical prediction of planetary orbits within a heliocentric framework. With various theories, observations, and proofs, we evolved our thinking about our solar system from an Earth-centered model to a Sun-centered model. Thanks to the effort of various scientific communities working together, this has helped us as a civilization to move forward. Thanks for watching.